This is geometry lesson 9.2. We're looking at prisms and cylinders. So we are starting to move into three-dimensional shapes over the next couple of weeks. We'll be studying all different kinds of shapes, and we'll look at defining what fits inside of them, what kind of area they have on the outside, all different things that we can calculate. But as we kind of just move into this section, we're really going to focus on some vocabulary and identifying some of these three-dimensional shapes. So today we're going to look at prisms and cylinders. Big Idea says that they are two special types of cylindrical surfaces. All right, so when you see the word cylindrical, you probably think of cylinder, but prisms, which are not cylinders, are also cylindrical surfaces. So we're going to go ahead and break down this vocabulary and make sure we understand what fits with what. All right, so starting off with just the basics. A surface, when we use that word, a surface, that's any three-dimensional figure that separates space into two regions, an interior and an exterior. So just think about a box that you get in the mail from Amazon. We would call that a surface. Okay, it separates space into two regions. What's inside of it, the air, the space, whatever's inside of the box, and the exterior. So it's creating this boundary that separates space into two things. That is called a surface. And then a solid is a union of a surface and its interior. So basically, a solid is something not like a box, something that has an inside that's connected to the outside. Sometimes this is best just looked at as an example. So a balloon is a surface. A balloon doesn't have anything on the interior except air. Okay, so it's just a surface. It has that outside that separates space into two regions. Whereas a bowling ball, both depending on the size and shape of the balloon, could be looked at as a sphere, right? They're circular. You could get a balloon that actually looks like a sphere and is in the same exact dimensions as a bowling ball, but the balloon is always going to have nothing inside of it except air. Of course, you could fill it. But a bowling ball would be considered a solid because the interior is connected to the actual surface itself. Okay? All right, so start breaking these down. Again, today's all about vocabulary and what you can identify. So you've probably heard the words cube and cylinder and maybe prism. And those are three-dimensional figures that are called cylindrical solids. And you can see them over here on the right. So this kind of gets into the weeds. I just want to highlight the most important things that we need to know. So we're going to hear the word face a lot. All right, so when a plane intersects a surface in a polygonal region, that just means in a shape, that is called a face of the surface. All right, so these shapes are all going to have different faces on the top, on the bottom, on the sides. Okay, those are the faces. The sides of the polygonal region, so if we look at just one polygonal region, that just means one of these sides. So for instance, let's take this side. Of the three-dimensional shape, that would be considered a face. The sides of that specific shape, so we're just talking about the sides of this two-dimensional square or rectangle, those would be called the edges. Okay, so if you were holding this box, the flat part here is the face, kind of the pointy edge would be considered the edge of the surface. So those are terms we kind of use in everyday life, so that should kind of make sense. But those are actually the sides of this rectangle that's on the side. So the sides of that are the edges of the surface or the three-dimensional shape. And the vertices of it, so the vertices would be the corners of this rectangle. Those are also considered the vertices of the surface. So the pointy edges are the vertices, the long edges are actually called the edges, and then the flat surfaces are the face. All right. So the definitions of a cylindrical solid and a cylindrical surface. Cylindrical solid is your set of points between a region and its translation image in space. That sounds complicated, but I'll make that make sense, including the region and its image. The boundary of a cylindrical solid is called the cylindrical surface. So just the outside of this solid would be called the surface, as if it was an empty box. A solid is everything, including what's inside of it. So basically where this comes from, and to try and make sense of all these fancy words that we've got right here, So we have a translation image in space, and I've kind of got an example right here. So we've got this pentagon, and here's the translation that's going to happen. We're going to take this and we're going to translate it up this amount from Q to P. And you can see that's happened here in the second picture. We started with our pentagon right here on this plane, and then we've translated it up to this new spot. And so those are going to be called the bases. So the region that we started with that was translated, the top and the bottom is what you would consider that here of this prism. That is called the base. And those bases then are connected by all of these lateral faces. And we'll get into that vocabulary. But that's what a cylindrical solid is. If we just talk about this as the outside of it, that's the surface. If we talk about the whole shape, including what's inside of it as a solid, then it would be a cylindrical solid. So notice this doesn't look like a cylinder. It's still considered a cylindrical solid. Okay, it's got its bottom and its top that are matching bases. That one is a translation of the other. So you have all these examples up here of cylindrical solids. They all started off as a base that then was translated and then connected. Okay, they're not always going to go straight up. They can tip to the side, and we'll talk about what those are called as well. But that's the basics of a cylindrical solid. It starts off as one base. It's been translated somewhere. Okay, and now those two bases are connected to each other. All right, the rest of the surface is called the lateral surface. So these outside pieces here would be considered the lateral surface, whereas the bottom here is the base, as is the top right here. So the top and the bottom, the matching sides there would be the bases, and then their connections here, which are always going to be parallelograms because it's connecting a flat side to a flat side, regardless of the shape. The only difference there would be looking at an actual cylinder with circles, but if we unroll that whole lateral side there, it actually turns into a rectangle as well. All right, so looking at these now, these are going to be the lateral sides. At a certain point, we'll be talking about finding the lateral surface area, so that would be not including the bases, that's just including these sides. So we're going to call these lateral faces, such as the parallelogram here that I've highlighted, AEEA, the image of a couple of those. All right, and then the intersection of two lateral faces is called a lateral edge. So all the way around the outside of this, if we've got these lateral faces here, and if this was a regular polygon, these would all be the same size. So the lateral edge is just where those two lateral faces are meeting. And the height or the altitude of the solid, of the three-dimensional shape, is the distance between the planes of its bases. Okay, so the distance from here to here, from one base to the other, that's going to be the height or the altitude of the three-dimensional shape of the solid. And so in this one I've highlighted here, that would be, so this is talking about in a different figure, the height being df. But here I've shown you from D to D there, that's going to be your height. And when the translation vector is perpendicular to the planes, okay, we're going to call this a right solid. So if we kind of slide up here a little bit, this cylinder, this prism right here, this one here, those would be considered right, because if I go straight from one base to the other, I'm hitting it at 90 degrees. Okay, whereas these other ones are slanted. If I go from here to here, right, that angle right there is not 90 degrees, and those would be called an oblique solid. So a right solid stands straight up like many of the three-dimensional shapes we're used to in real life. But like if you look at this one right here, this pentagon, it's leaning sideways, right? This would not be considered a right solid. If I go from here to the middle of the other base, they're not going to hit at 90 degrees. That would be considered an oblique solid. All right, so quick example, make sure we've kind of gathered some of that vocabulary and information. So the surface on the right is made up of 6 rectangles. Those 6 rectangles would be considered the lateral faces, and 2 regular hexagons. The top and the bottom are hexagons. They tell you they're regular, so that means all these sides are the same. Those would be considered the bases. So in the solid shown at the right, identify a base, which we just talked about. It's either one of those hexagons, a lateral face, one of these rectangles on the side, and a lateral edge, which is the edge that connects one lateral face to another lateral face. And then finally, tell whether the solid is right or oblique. So let's do this one at a time. First, let's identify a base. So the base is either the top or the bottom here, and it's a hexagon, and we're going to name it hexagon A, B, C, D, E, F is one of the bases. The other base would be the hexagon on the bottom, which we don't have all the letters here, so the best one to use would be the top there. So one of the bases is hexagon A, B, C, D, E, F. All right, so there's a base. How about a lateral face? Lateral means the sides that connect base to base. So any of these rectangles would be considered a lateral face. Let's go ahead and just use this first one. So we know that this is a rectangle, and we will call this FEOP. All right, and you could have chosen any of these rectangles here that goes from one base to the other. Those are your lateral faces. And your lateral edge is going to be where these faces touch. So I have a lateral face here, a lateral face here. This edge that connects them, that shared line, that shared side, that's going to be considered your lateral edge. Okay, so that is just a line segment, and that one specifically would be FP, but it could have been AQ or EO or DN. What it can't be is like FE. That's an edge, but it's not a lateral edge because it's connecting a base to a lateral face. So a lateral edge connects one lateral face to another lateral face. And then finally, is this a right or oblique solid? Now we don't have any angles given to us, but it's safe to assume here this looks like it's going straight up and down. If I connect the center of the base on the top to the center of the base on the bottom, it's going to hit at 90 degrees. Okay, and so this is a right solid. It is not leaning to the side. If I took this and I translated it over this way and then connected it, now it would be oblique, but this looks to be a right solid. Okay, now we're going to kind of break these down into two different categories. So the two types of cylindrical surfaces that are particularly common that we're going to study are the cylinder and the prism. Okay, so they are both cylindrical surfaces. I always have trouble with that word. So it's two bases, identical, and they're connected. The only difference between a cylinder and a prism is what their bases are. So a cylinder, the base is a circle. Okay, so we started off with this circle. It's translated. Sometimes it will go straight up. We've looked at ones that can also be oblique and tilted, but it's a base translated to another base connected, and the bases are circles. That would be your cylinders. And a prism is any other cylindrical surface whose base is just a polygon. So here we've tilted it on its side. The bases would be the triangles. One of these was translated to the other, and they're connected. The bases are a polygon. So this is a triangular prism. We name them by their bases. Here's another triangular prism. The bases are triangles, and they are connected. But you can also have a rectangular prism, again named by its bases. And then jumping forward, if all the sides are squares, then we would call that a cube. So it's a very specific type of rectangular prism because all the sides are rectangles, but specifically if all the sides are squares and they're all even, then we call that a cube. So just to kind of, now I've already gone through all of it, but just to reflect on it, the base of a cylinder must be a circle. It's very specific. But the base of a prism can be any polygonal region. So we said triangles, squares, rectangles. It can be a hexagon, a pentagon. Those would all just be considered prisms. The faces of the lateral surfaces are always parallelograms. So when we connect these, we're connecting a side to a congruent side because these two bases are congruent or equal to each other. So it's always going to form a parallelogram when they connect. If it's a right prism. These are going to be rectangles, but if it's oblique, then they're going to be just parallelograms. Many prisms you'll encounter will be right prisms whose bases are regular polygons, so not this one, but if it's a square it is, or if it's a regular pentagon, regular hexagon. These are called regular prisms, so we can define the entire three-dimensional shape as regular if the bases are regular shapes. An irregular prism is a right prism whose bases are regular polygons, so they're going to be connected straight up and down. So our example up here, right, this is a regular prism. I'm trying to refer, here we go. It's a hexagon, so this would be a regular hexagonal prism. So we name it for the shape of the base, and if it is a regular hexagon, not because it could just be a random hexagon, 6 sides, but not all the same. But if it is regular, then we use that as part of the naming process. All right, if we want to indicate that we're including the interior, we can add the word solid. So that means it's filled all the way through. So we can include that in our description. So you could say a solid, regular, hexagonal prism. So prism tells you the basic shape. Hexagonal tells you the bases. Regular tells you that it's a regular hexagon. They're all the same size. And then solid means it's filled. All right. And then we talked about a cube. And so all of this can be organized in a hierarchy. We look at these hierarchies all the time. So everything we've studied today falls under the cylindrical surface. You've got a base connected to another base. That's the translation of one of them. If we have the bases being circles, they would be defined as cylinders. Cylinders can be a right cylinder. They go straight up and down like this, or an oblique cylinder if they are tilted sideways. If the base is not a circle, if it's a different shape, we're going to call that a prism. Again, they can go straight up and be a right prism, or they can tilt sideways and be an oblique prism. If we have a right prism, it could be a regular prism. Okay. It also could just be a box. And if we go ahead and combine both of those, so a box is a rectangular prism here. It's going to go straight up and down, but not all the sides are equal to each other. So if we have a regular prism combined with a box now, all the sides are equal. We call that a